In this lecture, I'll show you how to calculate a very big random integer number. This is somehow difficult in Solidity because Solidity doesn't have a specialized function that returns random numbers. So we must construct our own function in the following manner. So let's create a function simply named random. This function is public. Of course, this function can be private because it will be called only from inside this contract. But I will call this function from this application, from Remix application. This is a web application, and it will be hard to access a private variable from here. So I'll make the function public only to be easily accessed from Remix, from this part from here. So public, this function is a view function, it doesn't modify the blockchain, and it returns an uint256 value. A very big unsigned integer number. Inside the function, we'll use a hash function that calculates the hash of its arguments, and after that we'll convert that hash to an unsigned integer. So we'll use the kexak256 hash function like this. This function will return the hash of its arguments. So here I need something random. For example, block.difficulty is somehow random. Block.timestamp is a random value. We can't know in advance at what time will this block be mined. So this block that contains our transaction. And another random value is players.length. We don't know how many players will enter our lottery. So we can assume that these three values are random. They are not really random because the miner can modify or can set a specific timestamp. The difficulty can be known by the miner in advance, and also somehow the miner could know how many players entered the lottery. So this function will not return a perfect random number. It's only for our example here. And now this function returns a hash that will be converted to an unsigned integer of size 256 bits. So uint256. This is how we convert a type to another type, and I return this value. Now let's test our function. I deploy the contract, and here, pressing on the random button, I get a very big random unsigned integer. This is my random value. If I press it one more time, I get another value. One more time, another value. So we can assume that every time we call this function, it returns a random value. One more time, pay attention that this function can't be used in a decentralized lottery that has access to a large amount of ether, because these values from here are not 100% random. So a miner, a malicious miner, could somehow exploit this function.